John Radnick from Constellation Audio, and I'm here to talk about our line of electronics. Constellation Audio was started about 2.5 years ago. The founders of the company were the same folks that started Continuum Audio, which is a company that makes two very highly respected turntables and tone arms. My task as VP of Engineering for these products was to create amplifiers, preamplifiers, and other products which were of the same level of performance that their turntable has achieved. So to do that required bringing together a team of engineers who I thought were really the best in the industry in their various areas of expertise. So, for example, we have asked John Curl to do our phono preamplifier. John has been my own mentor and teacher since early 1980s when I worked with him on another preamplifier project. So the preamp design is in many ways based on something that John and I had worked on quite a long time ago. Power amp is based on technology that has been developed by an engineer named Bascom King. Bascom's been involved with high-end audio and tube electronics for almost 45 years. He used to write for Audio Magazine, but he's been an engineer for high-end audio components for quite a long time. And this design is based on a 1930s, early 1940s tube topology, but done with MOSFETs and FETs. We also have in this line digital electronics, which were developed by my own team of engineers from my days past when we had a company called Audio Alchemy. We've done quite a lot of digital audio engineering since that time, but the same team of people, Mr. Keith Alsop, Cedric Beza, Ken Samuel, and Richard Liddell are all the same folks that work with us at Audio Alchemy. My charge, what I was told to make sure we had with this line of electronics, besides being the equivalent quality to their turntable, was to be sure that we were transparent, quiet, highly detailed, lots of dynamic range, but not hard and edgy, not solid state sounding, but not tube sounding either. So we've chosen topologies that we think complement those goals. One of the things that we've done is, for example, in the preamplifier, is to be sure that vibration control has been taken care of to the biggest degree. So all of the chassis are very massive. They are internally we use suspension systems to float the circuit boards to prevent vibrations from getting to them. We also use damping materials within the system that suspends the circuit board so that there's no vibration that actually gets to the individual boards at all. When we do this and combine that with very, very quiet power supplies and very good grounding techniques, our preamplifier has gotten a measured noise floor of around minus 140 dB, which is very, very quiet, about the limits of what test equipment can reach. So our goal then of having an ultra-quiet background has certainly been achieved. Another thing we do is, in the preamp, there are no mechanical switches or volume controls that use any contacts, any wipers. It's all done electronically using something called an LDR, light-dependent resistor. And these are real resistive elements that have an LED, very bright LED that shines at them internally. And you can control the resistance of them by varying the brightness of the LED. So you can use these as switches by changing them from high resistance to low resistance to allow signal through, or you can use them as resistive dividers, like a volume control, by carefully controlling the current of each of these LEDs, which we do using high precision digital analog converters and a microprocessor that maps all of the currents required for a very smooth range of dB control from 0 to minus 100 in 10th dB steps for much of that range. The amplifier also has vibration control, mass-loaded chassis. It is a slightly different topology. As I mentioned before, it's based on an older tube design where it's single-ended, but of course MOSFETs instead of tubes. So you have two single-ended amplifiers, one for the positive phase and one for the negative phase, and a bridge across them for the full signal. Each amplifier contains one of our line stage modules as a preamp section or as a driver section if you need it. But if you're using a Constellation product, you actually can bypass this. We have something called Constellation Direct, and you are able to go around that input stage because you only need one, and it's in the preamplifier. Phono preamplifier is as I said, a John Curl design. It's also very, very quiet. It has adjustable gain. It has moving magnet and moving coil inputs, at least 3 of each. It has adjustable equalization in the case of the more expensive unit, the Sirius. It has remote control cartridge loading, so you can adjust your cartridge load from 0 to 1,000 ohms continuously from the remote control while you're listening to it. And like all Curl designs, it's very fast, very, very quiet, very lifelike, very transparent, and meets the goals that we want to achieve. Here at this show, we are for our first time showing our performance series of electronics, which are a somewhat lower cost version of our original designs. Electrically, the same schematic, the same design topology, but accomplished using somewhat less expensive components and manufacturing techniques. In that line, there's also preamp and power amp and phono preamp, but there's also a digital music DAC and player. So we have a discrete DAC where we have our own DSP and FPGA-based DAC elements, and a built-in Linux server that feeds USB data, or it brings in USB data off of a USB stick or a hard drive and converts it to I2S audio. That I2S then goes straight into the DAC. There's no interface in AES-CDU or SPDIF or USB. So you get really the best conversion of your digital audio files into music.
Thank you very much.
I hope that helps. Thank you.
Thank you.
Yep.